Hello, welcome back. Today we are going to review the integer operations unit of MathB. Before we learn how to do stuff to integers, we must first define what exactly an integer is. To do that, we will return to the number line that we are used to. It starts at 0 and goes to infinity, with ticks at each whole number, and the rest of the real numbers filling in the gaps. We can visualize addition as moving however many ticks to the right. For example, to add 2 to 2, we move right 2 units, starting from 2, which gets us 4, which aligns with the fact that 2 plus 2 is 4. We can visualize subtraction in largely the same way, just moving left instead of right. For example, to subtract 2 from 5, we move 2 units to the left, which gets us 3, once again aligning with number subtraction. This may seem very elementary, but it is a good way to understand the gaps that the positive numbers leave. Let's think about what would happen if we tried using one of our familiar operations, subtraction, but subtracted a number larger than the number it is being subtracted from, like on the screen, where we subtract 2 from 1. We can see that this would get us a number that isn't on our number line, so mathematicians expanded the number line to include these numbers. These numbers that are further left than 0 or less than 0 are called negative numbers, and we can see that the previously described subtraction operation now lands on a number, -1 to be specific. Now we can see that both addition and subtraction can always be performed as the number line goes to infinity in both directions. And this is the integer number line, specifically the whole numbers, not the numbers at the gaps. Now, to answer our question more definitively, any whole number or negative conjugate of 1 is an integer, which just means that the whole numbers and the negative versions. However, this new number system also brings new challenges, the first of which is understanding the difference between size and significance. First, the simpler and likely more familiar of the two, size. To be larger in size just means that the number is further right on the number line, and to be smaller means further left. Size is measured using some symbols that I hope are familiar. These 4 symbols depict different relationships regarding size that a number can have with another. For example, -1 is less than 3 because -1 is further left on the number line than 3. Another example is that 4 is in fact greater than or equal to -2. Specifically, it is greater because once again 4 is further right on the number line than -2. Before we move on to significance, I want to point out that any time you are confused by a question in this unit, I recommend drawing a mini number line because they are great for explaining many concepts covered here. Next, significance, which is measured using a new function called the absolute value function. It is written like so and read as the absolute value of a. To say that a number has greater significance, we can say that the absolute value of a is greater than the absolute value of b. Now, to calculate absolute values of integers, we must understand what exactly it does, which is rather simple. It measures the distance from 0 or the origin on the number line. What that means in practice is that positive numbers stay the same as their distance is just their point, and negative numbers stay the same but become positive, because distance can't be negative. An interesting relationship this creates is that the absolute value of a number and its negative version are equal. On the number line, this function looks like this, with lines going from the negatives to the positive dots on all the whole numbers. Let's return to our main 2 operations and learn how they work on integers. When done with positive numbers, addition goes to the right and subtraction to the left, as previously stated. But what if we wanted to do these operations with negative numbers? -5, for example. Well, because the second number is negative, the directions flip and addition goes to the left and subtraction to the right. But what if the base or first number was negative? Well, the solution is simply starting on the left side of the number line. Let's do a few examples now. 4 plus -3. So we start at the base, which is 4, and we would go right because it's addition, but it's a negative number, so instead we go left, 1, 2, 3, and get to 1. Next, 1 minus -3, again we start at 1, subtract, which should go to the left, but it's negative, so instead we go to the right, and we get to 4. One last example. -2 plus -4. We have to be careful this time because the base is negative, so we start on the left side at -2, and we would go right because it's addition, but the number's negative, so we go left 4 and get to -6. So to quickly summarize, adding negative numbers is the same as subtracting the positive version, and subtracting negative numbers is the same as adding the positive version. These same principles extend to larger numbers. I just used relatively small ones as examples, and if you ever forget, you can always draw a number line. For division, the process is almost identical. We first do the division ignoring the signs, which in this case is 8. Then we ask once again, are the signs the same? And they are not, so it becomes -8. And that's all for multiplication and division, but we still have one last thing to cover this unit. Integers with exponents. And there's just one thing that you need to remember for this, and it's the fact that exponents are really just repeated multiplication. For example, -11 squared is just -11 times -11, and if we remember how to multiply integers, we would get 121. A pattern that you might notice is that a negative number yield positive results when raised to even powers and negative results when raised to odd powers. This is because a negative number times another negative number is a positive number. And that's it for this unit. Now let's do some comprehension questions to review. Pause to try them out. And here are the answers. Thanks for watching. I hope you enjoyed and learned something. See you next time.